All right, everyone, get ready for this, because today we're diving deep into the world of a true AI visionary, and this one is a big one.
Huge.
Olivier Faugeras.
Olivier Faugeras.
And we've got excerpts from the article, and it's called, quote, Olivier Faugeras, Visionary in AI and Computer Vision, end quote. And trust me,
That's a good one.
you're going to want to stick around for this one.
Oh, yeah.
If you've ever, I think we've all wondered how computers, learn to see and understand the world. Well, this guy, Olivier Faugeras, played a huge
massive
part in that.
Yeah, and what's really fascinating about his work is that it kind of goes way beyond just programming computers. You know what I mean? He brought this deep understanding of math, specifically geometry, and applied it to the challenge of computer vision. He essentially kind of gave machines a new way to think about the 3D world based on 2D images.
So he kind of gave computers a geometry lesson.
Yeah, basically.
That's kind of a wild concept.
It is. Imagine teaching a computer to understand depth and perspective just from a flat picture.
Right.
That was the hurdle. And so Faugeras found a way, and he used something called projective geometry.
Oh.
It's a little complex, but think of it like this. If an artist can use perspective to create the illusion of depth on a canvas,
right,
why can't a computer use math to do the same thing, but in reverse?
Ah. Okay, so I'm starting to see the connection here.
Yeah.
So instead of creating a picture, the computer's using math to kind of deconstruct it, to understand the 3D world that's kind of hidden within that flat image.
Exactly. But to really get I think we need to rewind a bit and look at Faugeras' background.
Okay.
This wasn't just some hobbyist, tinkering in his garage. This is a guy with some serious chops.
Yeah, the article mentions some pretty impressive credentials. École Polytechnique, a PhD in computer science.
This guy was no slouch.
This guy was no slouch when it came to the world of numbers.
No, and he had an incredibly strong foundation.
Yeah.
And that led him to INRAE, which is this leading French research institution.
Okay.
And he was surrounded by brilliant minds in AI and robotics.
Right.
It was the perfect environment to foster this groundbreaking work.
So it sounds like the right mind, the right skills, and the right environment all kind of came together at the same time.
They did. It did.
But what was it specifically that he did?
Yeah.
That revolutionized computer vision?
So he tackled one of the biggest challenges in the field, teaching computers to quote see in 3D.
Right.
We humans, we take it for granted, but think about it. Our eyes, they capture flat images, but our brain combines them to create a sense of depth.
Right.
For Faugeras, he figured out how to do this for computers using, you guessed it, more geometry.
And that led to things like self-driving cars. I mean, they need to be able to see in 3D to be able to navigate.
Right. You're absolutely on the right track. His work is foundational to so much of the technology that we use today. But let's focus on one key area.
Go ahead.
Stereo vision.
Oh,
okay.
Familiar with that?
Yeah. Is that like those old 3D movies with the red and blue glasses?
Exactly. Each eye gets a slightly different view.
Yeah.
And your brain combines those two images to create depth.
Right.
So Faugeras developed ways for computers to do the same thing, using this concept called epipolar geometry, which basically it describes the relationship between two images of the same scene, but taken from different viewpoints.
Yeah.
So you got two cameras, slightly different angles, and you can use those two images to figure out depth.
So he essentially taught computers to see humans do with two eyes working together to understand depth.
Precisely. And keep in mind, he was doing all this
long before
the day
we had the kind of computing power and massive data sets that are common today.
Right.
So it's quite remarkable when you think about it.
Yeah, it really is. Now, the article also mentions neural networks. Mm-hmm. Wasn't that something he was working on way before they became the big thing in AI?
He was. Long before deep learning became a buzzword, Faugeras was already exploring how neural networks could be used for tasks like image classification.
Oh, wow.
He was truly ahead of his time in recognizing their potential for computer vision.
Okay, so we've got the math genius, we've got the 3D vision pioneer, and now the early adopter of neural networks.
Right.
But the article hints that his influence went like beyond just computer vision.
Mm-hmm.
It mentions him bridging math and AI.
Yeah.
In a broader sense.
Broader sense.
What does that even mean?
Well, Faugeras was a firm believer that mathematics, specifically geometry and even something called topology, held the key to unlocking the true potential of AI.
Okay.
And this wasn't just about, vision. He saw these mathematical principles as fundamental to the entire field.
Hold on. Topology, isn't that like the study of shapes and how they can be deformed without tearing or gluing?
Right.
I don't quite see how that connects to AI.
It might seem like a stretch at first, but topology actually, it helps us understand like the fundamental properties of shapes and how they relate to each other.
Okay.
And this turns out to be incredibly useful for analyzing complex data, even the kind of data used to train AI systems.
So this wasn't just about like teaching computers to see, Faugeras was looking at the very building blocks of intelligence, both human and artificial,
right,
through the lens of mathematics. It's pretty mind blowing when you think about it.
It is, and that's just the tip of the iceberg. Next, we'll delve deeper into his collaborations and the real world applications of his work, because Faugeras didn't just theorize.
Right. It built bridges,
yeah,
connecting with experts across disciplines to bring his ideas to life.
Well, I can't wait to hear more about that. This is getting more and more fascinating.
It is, right?
Let's dive into that in part 2.
Welcome back. Last time we kind of left off talking about Faugeras's vision of math as like this key to unlocking AI,
yeah,
but he didn't just like sit in a room, crunching numbers. He was a master collaborator.
Well, which makes sense, right? Because AI it's such a multifaceted field. You've got, computer science, engineering, math, even neuroscience kind of in the mix.
Yeah.
It seems like collaboration is kind of key to making real progress.
Exactly. And Faugeras understood this. He worked with researchers and institutions globally, kind of bringing together diverse expertise to tackle these complex challenges.
Yeah, the article mentioned some pretty cool projects that came out of these collaborations.
Yeah.
Is there anything that stands out in particular?
Well, his work on multi-camera systems is a great example.
Okay.
These systems, they use multiple cameras to capture a scene from different angles, are essential for things like, autonomous driving and surveillance. But to make them work, you need expertise in optics, computer science, electrical engineering. Faugeras was a driving force in bringing these different disciplines together.
So he wasn't just like a brilliant researcher. He was also kind of like a conductor, like orchestrating.
Yeah.
All these different...
Being pulled together.
Yeah, all these different talents to create something truly innovative.
That's a great way to put it. And his work on stereo vision, which we talked about earlier, was another prime example of successful collaboration. Remember how he used epipolar geometry to help computers perceive depth? Well, that involved a team effort,
right,
combining expertise in computer science, engineering, and applied mathematics.
Right. It's like all these pieces fitting together to solve this incredibly complex puzzle.
It is, yeah.
But the article also mentions that Faugeras' work had an impact.
Beyond
just AI, reaching even into the field of neuroscience.
That's right.
How is that even possible?
That's where it gets really interesting.
Okay.
Faugeras' mathematical frameworks, the very tools he developed to teach computers to, quote-unquote, see, also turned out to be incredibly valuable for neuroscientists studying how our own brains process visual information.
Wait, so his work on machines actually helped us understand how humans see.
Exactly. His mathematical models provided new ways to analyze how the brain interprets depth, motion, and spatial relationships. It was a true interdisciplinary exchange with insights flowing back and forth between AI and neuroscience.
Yeah, it's amazing how these seemingly separate fields can kind of inform and enrich each other.
Totally.
It really highlights the interconnected nature of knowledge, doesn't it?
It does. Now, while Faugeras was clearly a visionary, he wasn't working in a vacuum. The field of computer vision was full of brilliant minds pushing the boundaries of what was possible.
Right.
The article specifically mentions David Marr and Takeo Kanade.
Okay.
Are you familiar with those names?
Yeah, I'm curious about that too. I mean, they're all considered pioneers in the field.
They are.
But I imagine they had like different ways of approaching the problem of computer vision.
You're right. Marr was very much focused on like the theoretical side of things.
Yeah.
He wanted to develop a comprehensive computational theory of vision, based on how the human brain processes visual information.
Okay.
He was all about understanding the WHY, like the underlying principles.
So he was like the architect kind of designing the blueprint for how a vision system should work.
Yes.
Based on our understanding of the brain.
Perfect analogy. Kinnaid, on the other hand,
okay,
much more pragmatic. All about developing like efficient algorithms that could be used to solve real world problems. Facial recognition, robotics, those sorts of things.
So Marr was the theorist, Kinnaid the pragmatist.
Yeah.
Where does Faugeras fit into this?
Faugeras was the bridge builder.
Okay.
He combined Marr's theoretical depth with Kinnaid's focus on practical application.
Okay.
He wasn't content with just developing theories. He wanted to see them implemented,
right,
turned into like working systems that could solve real world problems.
So he kind of took the best of both worlds, kind of bridging that gap between the abstract and the concrete.
Yes.
That's pretty impressive. But I'm guessing it wasn't all smooth sailing?
No.
The article hints at some challenges that he faced.
Mm-hmm.
What were some of the like hurdles he had to overcome?
Well, one of the biggest challenges was simply the limited computing power available at the time.
Right.
Imagine trying to run like complex 3D reconstruction algorithms on computers that were like slower than the smartphones we carry around today. It was a constant battle against like technological limitations.
Yeah, that must have been incredibly frustrating. You have these brilliant ideas,
right,
but the technology just isn't there to fully realize them.
Exactly. And translating those theoretical advances into practical systems that could operate in the real world presented another set of challenges.
Right.
Early vision systems were notoriously sensitive to things like changes in lighting, shadows, or even just noise in the image sensor.
So even if you had like the perfect algorithm, getting it to work reliably in the messy real world was a whole other ball game.
Absolutely.
It makes you appreciate how far we've come.
It does. But it's important to remember that even the most groundbreaking work has its limitations.
Right.
And Faugeras' research was no exception. Some argued that his emphasis on mathematical rigor made his methods less accessible. Okay.
To those without a strong math background.
So his work could be a bit intimidating.
Yeah.
To the average engineer or computer scientist who might not have been as deeply steeped in mathematics.
That's one way to put it.
Yeah.
But remember, he was laying the foundation for an entire field.
Right.
Sometimes you need that level of rigor to ensure that the building blocks are solid.
Right.
You know?
Fair enough. But were there any other criticisms of his work?
Yeah.
Besides its technical complexity.
Yes. Some pointed out that his models often relied on certain assumptions. Like perfectly calibrated cameras, which isn't always realistic in real world scenarios.
Right.
This sometimes limited the applicability of his methods in more complex and uncontrolled environments.
So his work was revolutionary, but like any pioneering effort,
Sure.
it had its limitations. It's fascinating to see how even the most brilliant minds
face these kinds of challenges. It makes them seem a bit more human, doesn't it?
It does, and it reminds us that science is an ongoing process, a constant refinement of our understanding.
Right.
Now, with that in mind, let's shift gears and explore Faugeras' legacy in the modern world of AI.
Okay, great.
Yep.
Because we've talked a lot about his historical contributions, but I'm really curious to know how his work is perceived today in the age of deep learning and all these incredible advances in AI.
Right.
Let's dive into that in our final segment. All right. So here we are.
Back for more.
For the final part of our deep dive into the world of Olivier Faugeras. And
it's been a long one.
Yeah, we've covered a lot of ground.
A lot of crap.
From his mathematical genius to his pioneering work in 3D computer vision, even his collaborations that spanned continents and disciplines. It's been
quite a journey.
Yeah.
through the history of AI, but now I really want to bring it back to the present.
Right.
What is Faugeras' legacy today in this world of self-driving cars, augmented reality, and all these like mind-blowing AI advancements?
Yeah, is he still like actively involved in research?
A question.
Or has he kind of retired to a life of contemplation, like watching as his ideas shape the world from a distance?
Well, he might not be, publishing papers at the same pace as he did in his earlier years.
Right.
But Faugeras is far from retired. He remains a highly respected figure in the AI community. His work is constantly cited, and his ideas continue to influence new generations of researchers.
So he's kind of like the elder statesman of AI, the wise sage whose insights still guide the field.
That's a great way to put it. And his influence goes beyond just his past research. He's still actively involved in mentoring young researchers and shaping the future of AI through his work with institutions like INRAA.
That's fantastic. It's inspiring to see, those who laid the groundwork still so passionate about the field that they helped create.
Yeah.
But beyond his like direct involvement, how does his work connect to the AI advancements that we're seeing all around us today?
Well, I mean, think about the technologies that are rapidly changing our world. Self-driving cars, augmented reality, advanced robotics, all of these rely heavily on the principles of 3D computer vision, stereo reconstruction, and probabilistic modeling that Faugeras pioneered decades ago.
So every time we see like a self-driving car navigate like a busy street or experience like a cool AR app on our phone, we're seeing like the echoes of his work.
Exactly. His work on 3D reconstruction, for example, is fundamental to how self-driving cars perceive their surroundings and make decisions. And his contributions to stereo vision, using those two slightly different viewpoints to understand depth are crucial for robots and AR applications.
It really highlights the long-lasting impact of fundamental research.
It does.
That like planting seeds that take like years, even decades to fully bloom. But AI is such a fast-moving field.
It is.
With the rise of data-driven approaches like deep learning, is Faugeras' work still relevant?
That's a great question, and one that's being actively debated in the AI community.
Okay.
There's no doubt that deep learning has achieved like remarkable things in recent years. It's powering image recognition, natural language processing, all sorts of like amazing applications. But there's a catch.
Oh, what's that?
Well, these deep learning systems, they can sometimes be black boxes.
Oh, okay.
We don't always understand why they make the decisions they do. They can be incredibly powerful, but also somewhat opaque.
So it's like they're magically good at certain tasks, but we don't have the instruction manual, so to speak. We don't know the secret sauce.
Exactly. And this is where Faugeras' legacy becomes even more important. His emphasis on mathematical rigor, on understanding the underlying principles of AI systems is crucial, especially as AI becomes more powerful and integrated into our lives.
So he's reminding us that we need both. The power of data A&D, a solid foundation of mathematical understanding to build truly robust and trustworthy AI systems.
Precisely. As AI systems become more complex and autonomous, we need to be able to interpret their decisions, understand how they arrive at their conclusions.
Right.
Faugeras' work reminds us that math isn't just, an abstract tool. It's the key to unlocking the power of AI safely and responsibly.
Wow, this has been an incredible journey.
It has.
We've learned so much about Olivier Faugeras from his, brilliant mind to his lasting impact on AI and beyond.
It's been fascinating to trace his journey and see how his work continues to shape the field. And as we wrap up, I want to leave you with a thought-provoking question to ponder.
Wow.
As AI systems continue to evolve, becoming more complex and intertwined with our lives, how can we ensure that they remain interpretable and accountable, staying true to the principles of mathematical rigor that Faugeras championed?
That's a question worth pondering. It seems the future of AI depends not just on its power, but on our ability to understand and guide it wisely, building on the solid foundations laid by pioneers like Olivier Faugeras. Thanks for joining us on this deep dive. And until next time, keep exploring, keep questioning, and never stop diving deep into the fascinating world of knowledge.